Okay, we'll proceed from summation to integral. Okay, summation to integral discussion that we are pursuing, and we are trying to show that summation can be brought into integral calculus. This is possible. If someone is doing summation of items, if someone is doing summation of items, then how it can be brought into integral calculus? Why we have taken this path, that summation to integral calculus? Summation to integral calculus. The reason why taking this path, that many people, okay, we have talked that there are two ways that people can solve their problem. There can be many ways people can solve their problem, but there are primarily two ways people can solve their problem, and their problem can be transformed into integral calculus. It's possible. Why integral calculus? That we will see. Okay, one way is multiplication. If people are thinking the future of their solution, the future of their solution lies in the future of their solution, it lies in kind of in multiplication. A solution, what they have started, and then what is the future of the solution, what the way it will go through multiplication. Then they can think about calculus. Where they can think about calculus? If they are multiplying y into x in their problem, if problem comes to a stage where they need to multiply y into x, where y is function over x, y into x, where y is function over x. Okay, if that is the scenario, y into x, where y is function over x, what is that? Like y equal to sine x. Sine x into x. What is sine x into x? If if this kind of scenario is arising, y into x, in very simple way I can say area of rectangle is height by width. Area of rectangle is height by width. Is it the area of rectangle? Certain. This is the area of rectangle, that is height by width. Okay, thank you very much. Now I start, if I am now question is arising, I have written a function. I have written a function which calculates area of 2D shape. If I have two dimension shape, then area of 2D shape that I calculate. I have written a function. I want to write a function where I am calculating the area of 2D shape. Now someone is giving height and width in the function. Makes sense? Consider I am writing a Python function and saying area, func area. In that I am accepting y comma x. Y is the height comma x is the width, because I know people will give height and width. Now someone entered height as 10, width as 5. Okay, I return 50 is the area. I simply multiply. Y into x is the area. Okay, then someone entered height as 2 and width as 10, 2 comma 10. Then it is written as, now I reply 20 is the area. Thank you very much. Okay, now someone is entered y in the name of y, in the name of y as y as sin x, y as sin x, and in the x he wrote as 2 pi, means 0 to 2 pi, and y as sin x. Now tell me the area. Can you multiply sin x into 2 pi? 2 pi sin x, is it the area? Okay, I believe it is all right. The way I am saying it is all right. Okay, okay. If this is the sine wave, if this is the sine wave, and this point is origin, this is the sine wave, this point is pi, and this point is 2 pi. Make sense? Now I am trying to calculate area of this sine wave from 0 to pi. 0 to pi, what is the area underneath it? Okay, if it is a rectangle, If it is a rectangle, if it is a rectangle, then what is the area of this rectangle where height is this much, that is fixed, and width is from here to here. So I enter the height as y and width as x, I get the area. Now if I have to calculate same thing, area means area. If this is a rectangle, if this is a rectangle, then area is width by the height, width into height. If this is a sinusoidal wave, then area, what is the area? Now, the person who is calling the area function, he is not bothered about there is another area called sinusoidal area. He just want area, area, area. You are giving area, right? Okay. In the name of y, he is entering sine x, and in the name of x, he is writing, he is giving pi, means 0 to pi. Now tell me the area. Now you returned pi into sine x, and he made a cross sign. Wrong. Pi into sine x is not the area of sine x. Give me the area now. From 0 to pi, y is sine x. Now you claim y is varying. Every moment y is not same. If it is a rectangle, every moment y is same. Okay, this proves that you are trying to calculate the area through pictorial way. Y into x is the area. If y is the height and x is the width, in pictorial way it forms a rectangle. Anyway, if I don't go with the pictorial way also, I claim that y what you are passing, that is sine x, it is varying with the x. At different x, sine x value is different. Whereas if you pass y equal to 10 and x equal to 2, at every x y is same. So I can return multiplication. But here, either if I return multiplication, the answer is wrong. And what is true now? Sin x, if I consider x as x, then x into sin x will be the area, and it is not true. Because sin x is variable with a different x. If I vary x, then height, that is sin x, would vary. When x equal to 0, then sin x is 0. When x equal to pi by 2, then sin x is 1. When x equal to pi, then sin x is again 0. In between, with different x, height varies. Now at this moment, I cannot give the area by multiplying the height by width. So 2 pi into sin x is not the area. If instead of sin x, if someone had given us 2, then 2 pi into 2 was the area. So now the integral calculus comes into the picture if we are trying to calculate multiplication of two items, where one item is independent and another item is dependent upon it. Like sin x is the height, sin x is the height, y into x, y is the height, x is the width, where y height is variable with the x. At different x, y height is different. Means y is dependent upon x. So y into x cannot be the solution of the multiplication. Now it will term as y dx. X is from one limit to another limit. That is the actual multiplication. I believe it makes sense. So multiplication of two constant items can be written as normal multiplication, but multiplication of two algebraic items can be written as normal multiplication if these two algebraic items are not related to each other. What is x into z? Xz. What is x into y? Xy. No problem. But if y is y vary with the x, what is y? Y is y. What is x? X is s. Now tell me the area. You have given place a function area, right? Where y someone entered as y and x someone entered x. You return x into y. But in the y name someone entered sin x, and in the x he entered just x. Now when it comes to calculation of the area, where someone is returning the area through multiplication, or rather than area, consider a person has written a function called multiplication. I believe this is the better explanation. Consider a person has written a function called mul, multiply. Definition multiply, and he is saying y comma x is the argument. If someone passed 10 in 10 comma 2, then 20 he returns. Now instead in y someone is passing sin x, and in x someone is passing x. Now tell me the multiplication. Sin x into x, that is wrong. because multiplication of x sin x into x is not x sin x. Okay, multiplication can be solved through area way also. If I multiply 5 into 2 as 10, then I can consider a rectangle whose height is 5 and 2 as width. Calculate the area, that is the multiplication. If I am saying sin x into x, then this is x axis and there is a sine wave. Sin x into x will not be the area. The way rectangle height by width by the area. Because y into x, y is independent of x if I see the rectangle. At any x, y is not changing. Okay, in that fashion, calculation of area with normal multiplication will work. But if y at different x height is different, just multiplying by height with the width will not work because height is varying with the x. In that fashion, we need integral calculus. Now y into x will be transformed into sin x, that is y, sin x or y dx, where x is from lower limit to higher limit, underneath which it will give the area. So this is the one way that someone is proceeding in solving a mathematical problem and he is reaching to a stage where it is y into x, then he can transform into y dx because y is dependent upon x. Y would change at different value of x. There is another form where integral calculus is important. What is the another form? Another form is repeated summation. Person who is solving a mathematical problem, he is cutting down its problem into many parts, chopping the problem into many parts. And every part he is solving the problem and he is adding it. That is what he is doing. Okay, in that is called repeated summation. Repeated summation can be a single independent variable, dual independent variable, triple independent variable, four independent variable, quad independent. So what is single independent variable? Repeated summation. Repeated summation in single independent variable means consider there is a variable like this and he chopping the variable into n different parts. The problem has a single variable like area of a circle where variable is angle theta. He is dividing angle theta. Angle, if I talk about the circle, then this is radius. If I talk about the circle, then this is the radius. And radius will go all along 2 pi angle. Okay, this angle that is theta that goes spans 2 pi. I divide theta into n number of parts and each section will be like this. Each section will be like this. This is the first section, second section, third section, and angle between it I call it delta theta I. For the ith section I call angle between it is delta theta I, ith section. Okay, if I calculate the area of this section, then if I add all the section, I get the net area summation of I equal to 1 to n area of ith section. If I add this way, I can also solve the problem. One problem solving is width into height is the area. I need to multiply. Is it the only way that when I need to calculate the area, I go integral calculus? Not necessarily. Multiplication of any two items can be converted into integral calculus if one is dependent upon another. Integral calculus can be faced when we are trying to solve our problem by dividing the problem into many components and each component I solve it and add it together. This is called summation. Summation can also be brought into integral calculus. Okay, that is summation can be single component like only theta is divided into n part and then we calculate the summation. Summation can be in two dimension also. Okay, summation can be in two dimension also. Like this is x-axis, this is y-axis. This is x-axis and this is y-axis and this is vertical, z-axis. Now this xy plane, x-axis I chop it into n part and y-axis I chop it to n part. Now I have set of rectangles. Okay, each rectangle has a width of delta x and delta y. Now for one rectangle, I solve a problem. I'm not saying I'm going to the get the rectangle area. I'm not calculating rectangle area. With one rectangle, I'm trying to solve one problem. Like circle, if I divide the circle into many angles, in ith angle, I calculate area that has more than angle delta theta I. This is not only delta theta I am bothered about. Using delta theta I calculate the area there. Then I add all the area. I get the net area. Similarly, if I divide this two-dimensional x and y into small area, then for each area is delta x into delta y. Ith section in x and jth section in y will make the area will be delta xi into delta yj. Now using delta xi and delta yj, I will compute some calculation for the ithjf section like delta theta I section. And then I add for everything, I get the solution. This can be another scenario. Third scenario, Third scenario, third scenario can be I chop this x-axis into n parts. I chop this y-axis into n parts, and I chop this z-axis into n parts. Now I have a cubical region. So many cubical region comes into picture. Each has volume of delta xi into delta yj into delta zk. Now we have n to the power 3, n into n, cubes comes into the picture. If I solve a problem, if I solve a scenario for a particular cube and then add for all the cube or solve the scenario for each cube, if I add it, then it can also be brought into integral calculus. It can solve the problem, and I'm sorry, then he can solve the problem in that manner also. When integral calculus is required, if n tends to infinity, if person is solving a circle area problem or calculating the parameter of a circle problem by dividing the circle angle into n different parts where n tends to infinity. In that sense, calculation of each section is not possible because n tends to infinity. If I person is trying to solve a problem by dividing xy plane into n by n number of part, n square part, for each part he is solving the problem and he is adding it. But if n tends to infinity, then he cannot solve the problem. Then integral calculus comes into the picture. Similar here also. Okay, so in that fashion, now we are in phase of calculating the surface area of a sphere in the spherical coordinate system. Surface area of a sphere in spherical coordinate system by dividing the spherical coordinate system into n into when it comes to area, then we need to come to a two-dimension thing. When it comes to volume, then three-dimension thing. When it comes to length, then it is single dimension thing. Okay, anyway, like if I'm calculating the area of the circle, then delta theta and delta r comes into the picture. Okay, if I'm calculating the circumference of a circle, then more or less delta theta comes into the picture. That is single dimension. If I'm trying to calculate the surface area of a sphere, surface area of a sphere, then surface area will come, the surface area means two entity will come into the picture. If I'm trying to calculate surface area of a sphere, then two entities will come into the picture. What are those entities? There are three entities in a spherical coordinate system. If I use a spherical coordinate system to calculate the surface area of a sphere, then one is radius. In the spherical coordinate system, one is radius, one is theta angle that goes in flat. If I cut this sphere, this is x-axis, this is y-axis, and this is z-axis. Okay, if I cut this sphere horizontally, then it makes a flat region. In flat region is a circle. Makes sense? If I cut if I cut this sphere horizontally, then one circle will come. Circle is formed by radius and angle. That angle is called theta. Okay, if I cut this sphere vertically, then again one circle will come. I can cut the sphere vertically in any direction. That is called Z and XY plane axis. Z axis, if I cut vertically, then it will cut, then the plane, this is the plane, this is the plane. If this plane cuts this sphere vertically, then the cut will be known as Z axis, and it will take Z axis into the consideration. Okay, consider that I have what is involved if I cut this. This is XY plane and this is Z axis. Make sense? Now this is Z axis and this is XY plane. This is X axis. This is X axis, this is Z axis. This is Z axis and this is Y axis. If I take a plane, if I take a plane and cut like this, if I take a plane and cut like this, cut will pass through Z axis and it will pass through X axis. If cut is like this, then since it involves X axis, then it won't touch anything else, only Z axis and X axis. This 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 plane, then it is referred as XZ plane. If I cut like this and it cuts only Z axis and X axis, this is called cut in the XZ plane. If it cuts and it involves Z axis and Y axis, it is called ZY plane cut. If cut is going anywhere, if cut is going, if cut is not touching X axis, cut is not touching Y axis, cut is touching Z axis, and cut is touching XY plane. I'm trying to say like this. If this is if this is Z axis and this is XY plane, and someone is cutting like this, then he touched the Z axis and anywhere in the XY plane he is cutting. This cut will known as Z XY plane axis cut. Means this is ZX plane, this is ZY plane, then this will be called ZXY axis plane. XY itself is an axis. Okay, so anyway, now we are trying to see what are the independent component in the spherical coordinate system. If I take this sphere and this is X axis, this is Y axis, this is Z axis. Consider this sphere is centered at the origin. Consider this sphere is centered at the origin. If it is centered at the origin, then if I make it, this is X axis, Y axis and Z axis. If I cut it horizontally, it will evolve in a circle, and that circle will have different radius. At the center, circle will be biggest, where as I go up, circle will be smaller, smaller, and down also circle will be smaller. Each circle we have one radius, and radius is moving 2 pi angle. That angle is called theta, and that is the radius at that point. That is not the radius of the sphere. If it cuts at the center, then in that circle radius is the radius of the sphere. If I cut vertically in Z XY axis, Z and XY plane axis, anywhere, I can cut it. But all circle will come with the same radius. If I cut vertically in any angle, all circle will come with the same radius. Okay, but the angle when it differs, means it will be vertical circle. Okay, it is horizontal circle. If I cut like this is vertical circle. If I move the radius in the vertical circle, this radius will be radius of the sphere. All circle will be same, but here all circle will not be same. But in this all circle will be same, and radius when it moves, then it makes it the angle it changes, that is called phi angle. This is called theta angle, and radius of the sphere is understood. There are three coordinate systems in spherical coordinate, three axes in coordinate system, spherical coordinate system. One is radius, one is theta, and in vertical plane the angle is called phi. Okay, can we calculate the repeated summation through repeated summation? Now I am dividing this sphere into many area, n into n area. Make sense? Earlier I showed that if I have xy plane, I can chop x axis into n part and y axis into n part. It leads to n into n number of areas. N into n number of areas. Each area can be represented as I comma j. Area, bottom right, I comma j. Ith jth section in area, ith jth section. So each will have now identification as I comma j. Area 0 comma 0, area 1 comma 1, area 2 comma 2, area 4 comma 0. Like that. So many areas are there. Total number of area is n square. Similarly, to calculate the surface area of the sphere, now I have to cut down, I am cutting down this sphere into n square part. Each part area I will calculate and then I will add, I'll get the surface area of the sphere. Makes sense? Okay, now in that fashion, now let's calculate the surface area. How we will cut? Earlier we cut in x-axis and y-axis. Earlier we made a cut along the x-axis and y-axis. N number of cut, n number of cut. Now we will cut here. Now if I talk about the theta angle, okay. Now if I talk about the surface area of a sphere, then radius is constant everywhere on the surface of a sphere. It is not varying. What varying is the horizontal theta angle. Okay, and what varying is the vertical phi angle. On the surface of a sphere, if I take different point on the surface of a sphere, every one has same radius from the origin. Center of the sphere, every point on the surface of a sphere, the radius is same. If I take the sphere, then every point on the surface of the sphere, radius from the center is same. But if I vary the point here, if I vary the point horizontally, then angle is different. The different point angle would be theta would be different, but phi will be same. If I vary like this, if I vary in this fashion, theta will be same, phi would vary. Means at any point P, there are two circles. One circle is horizontal circle, and any point P, another circle is vertical circle. Makes sense? And at point P, I have one small surface area that belongs to I comma j. What is I comma j? The horizontal circle I divide into n part, and vertical circle I divide into n part. Now consider the vertical circle I divide into n part, the jth part. Jth part hits the point P, and horizontal circle I divide into n part, and jth part, vertical circle ith part. Okay, vertical circle, if I take any point P here and take the vertical circle where phi is variable, theta is constant, and I divide the vertical circle into n part, then this is the ith part. Now at point P, if I take the horizontal circle and divide into n part, then jth part is the point P. Make sense? Now, how I can calculate the a this ith comma jth area? If I know ith comma jth area, I can write my expression exp, expression for the statement for the expression for the area is summation I equal to 1 to n, j equal to 1 to n, area I comma j, I comma jth section area, that area, and then I equal to 1 to n, j equal to 1 to n, means if I add all the area, then I get the full area. What is the area of ith comma jth section? That I have to find in generic way so that I can add it all through. That is under question mark. Now, if I watch closely, then how I can calculate the area? Calculation of the area. Okay, now question is arising how I can calculate the area. Okay, how I can calculate the area of sorry. So how I can calculate the area? Consider this is horizontal circle and this is vertical circle. This is point P and this is horizontal circle. This is point P and this is vertical circle. Vertical circle phi varies. Horizontal circle theta varies. Okay. And this is point P. Around point P, what is the small area that I want to know? If I take point P and I talk about the jth section, this the horizontal circle I have divided into n parts. I'm talking about the jth section. What is the length of jth section when it forms angle with the center as delta theta j? What about vertical circle? Ith section, it forms with the center angle called delta phi I. Ith section, their jth section. Then what is the length of this? Okay, what is this point? Consider, now I'm talking about verticals. Consider vertical circle. Now this is the ith section on vertical circle. This is the ith section on vertical circle. What is the length of this ith section? What is the length of this ith section? This is the ith section in the word. This is the arc. What is length of this arc when this angle is delta phi I? What is length of this arc? Okay, if this point is P, just P. I'm not saying X, Y, Z or whatever it is. This point is P. Okay, this point is P1 and this is delta phi I. Delta phi I. Now I say that if this point is P, then there is another point along the curve. This is the curve of the circle. Along the curve, if this point is P and this is P1, then there is another point called P2. What is P2? P2 means P2 is a point if I move 1 unit of angle, means this is the kind of this is the radius. If I move 1 unit of angle, only 1 unit. What is your 1 unit? 1 unit can be anything. 1 picoradian, 10 to the power minus 12. Very small, very small. 1 unit. If I move 1 unit of high angle, then how much? What is the length that it is moving? Length it is moving. Make sense? If this is P, if this point is P, then this is called position vector P. If this point is P2, then there is a position vector called P2. If I subtract P2 minus P, P2 vector minus P vector, it will give the another vector, this vector. Length of this vector is the distance from here to here, and that is a straight line. That is not the curve line. Okay, straight line. But angle is very small. It is so small that curve line or a straight line does not matter. Give me that magnitude only. Magnitude is P2 minus P. It will come as a vector. Calculate the magnitude of that vector. You will get the length of this when you move 1 unit of angle. Make sense? Now I say I can write that, means this proves that P2 minus P. Now I can write P2 minus P magnitude. P2 minus P is the magnitude. P2 minus P magnitude is the length of this arc when per unit change in the movement. Okay. Now consider that arbitrarily I moved phi angle or any phi angle, delta phi angle I move. I'm not saying delta phi I. The ith section what I had taken, the angle was delta phi I. I say I move delta phi. Because of my delta phi movement, the position vector changed from P to P2. P2. Mind it that delta phi I, it is P to P1. I moved any delta phi from anywhere, not in the ith section. Anywhere, if I move delta phi angle, then it moves P to P2. Okay, then how much it will move if I move 1 unit of angle? Then P2 minus P magnitude divided by delta phi. Make sense? Okay, what is 20 by 4? Many times I give this example. What is 20 by 4? 5. Okay, 20 is numerator and denominator is 4 equal to 5. Not 5. Actually, it is 5 by 1. 5 by 1 means per unit of the denominator brings 5 unit in numerator. If I have numerator as 20 and denominator as 4, I am trying to find how much will be numerator if denominator is 1. Just divide it. Or I have two entity. One entity is 20 and one entity is 4. This entity is called y and this entity is called x. I want to know how much is the y per unit x. Then whatever the y is 20 and whatever the x is 4 divided, it will become 5 by 1. Means per unit of x is 5 unit in y. Similarly, if I want to know how much is the per unit, if there is one unit in angle, brings how many unit change in the P. From P to P1, what is the distance it is traveling? How much length I get if I make one unit of change? Then get any length and divide by the angle. That will be become per unit how much you are getting. This length is from P to P1. P to P1. So this is the length of P1 minus P vector divided by delta theta is the magnitude. This is the length we get per unit. Multiply per unit. Now multiply again with the delta theta I, delta phi I, delta phi I. If I have used word theta anywhere, make it phi. Delta phi I. If if change in the length, arc length is, if change in the arc length per unit phi angle movement is P1 minus P by delta phi magnitude, then how much is the length I get if I move delta phi I from P to P1, P1, P to P1. That was P to P2 for the single radian we are saying. Then it will become P1 delta P or P1 my P1. Hope I have confused. Okay. So beginning was I was talking about the ith section, and this point is P and this point is P1. Now I am talking about 1 unit of radian. 1 unit of radian, 1 unit if I move in angle, then this point is P and this point is P2. Okay, this point is P2. Earlier, the point for the delta theta I is P1. If I said anything, consider now like this. I don't remember much. So for phi I, ith section delta phi angle, we have point P and with the delta phi I, another point is P1. Another point is P1. Okay. Now, if I move 1 unit of angle, this point is P2. I am saying I move delta phi, any delta phi, then how much is the distance it covered from P to P2? Okay, then it will be P2 vector minus P, that is delta P by delta phi. That much per unit of angle movement brings that much unit of length movement. That is the arc. Okay, so I know per unit of angle movement brings delta P by delta theta magnitude, that much movement in the arc. Now I multiply with the delta phi I, that will give the length of the arc. Make sense? Okay, this proves that the length of the, if this is the vertical circle we are talking, if we are talking about the vertical circle, then ith section arc length is delta P by delta phi magnitude delta phi ith section, delta P by delta phi. Similarly, for the horizontal section, this is the ith section. This is the jth section in horizontal where theta is moving. When theta is moving, there where phi is constant, then jth section length will be delta P, again there delta P, position vector P to P2, delta P by delta theta, magnitude delta theta j. Okay, in that fashion, the ith jth section area, if there is a point P, if there is a point P here and around P I have one area, like that there are n square areas. Okay, ith jth section area, one arc length, that is a straight line actually right now, because we have taken delta theta j and delta phi I as very small. Arc length in horizontal circle and arc length in vertical circle. Okay, if I multiply these two, then I get the small area in pseudocode. So now the ith, I can say summation I equal to 1 to n, summation j equal to 1 to n, area ith jth section. If I do like this, I get the full surface area. Area of ith jth section is one length and another length multiplication. That will give the area, pseudo area. That is delta P by delta phi magnitude into delta phi I into delta P by delta theta magnitude delta theta j. Altogether it will come magnitude delta P by delta theta into delta P by delta phi or delta P by delta phi into delta P by delta theta magnitude delta phi I delta theta j summation. Okay, now delta P by delta theta is a vector because delta P is a vector. P2 minus P1 is a vector. Delta P by delta phi is a vector. Into delta P by delta theta is a vector. Multiplication of two vectors is not possible. Either we have to do dot product or cross product. We will take cross product because we are intended to calculate the area. Delta P by delta phi cross product delta P by delta theta magnitude delta phi I delta theta j and summation double summation will give the area of the ith jth section. Okay, means delta p. Now this is a calculation. This is a summation in dual dimension. We have phi and theta, phi and theta. Now watch our previous video. Now consider phi and theta together. It is one axis. We call it theta phi plane. Arbitrary one theta phi plane. Whereas theta is like this and phi is like this. They are perpendicular to each other. I consider a theta phi plane. So I can say theta into phi as theta phi single axis. Now it will be single axis. Now it can be rewritten as I equal to 1 to n, j equal to 1 to n, and then delta p by delta phi cross delta p by delta theta. It will come as function over theta and phi, more or less. Function over theta phi, function over theta phi axis into delta theta delta phi. I can rewrite as delta theta phi. Now we have come to a stage where we have kind of one single axis is there. The name of axis is theta phi, and this vertical axis name is function over theta and phi. This is theta phi and this is function over theta phi. Okay, in that fashion, we have summation now. Summation of function over theta phi, delta theta phi. Okay, double summation I can transform into single summation. I can rewrite as summation k equal to 1 to k equal to 1 to n square. Two summation were there, n square. Function over theta r axis, delta theta r axis in the theta phi and delta theta phi axis. If this is delta theta phi axis and this is function over delta theta phi axis, if I say function over delta theta phi at any delta, ith, jth, function over theta phi for the ith, jth section. So this is the height, function over theta phi over ith, jth section multiplied by this width, that is delta theta phi. This will give the area of this ith, jth section or kth section. I am writing kth now, kth section. If I add all the sub area, it will give the full area. Full area is nothing but integral calculus 1. So I can nicely transform into integral calculus now. Now the limit sign of theta phi from lower to higher, function over theta phi d theta phi. D theta phi, theta and phi are perpendicular to each other. I can rewrite as d theta d phi. It can be written as limit theta phi from minimum to maximum, function over theta phi d theta d phi. What is your function over theta and phi? This limit I can break theta and phi. Theta is going 0 to 2 pi and phi is going 0 to pi. This is a spherical coordinate system. What is this function over theta and phi? That is delta p by delta phi. I can convert into dp by d theta. The way we converted into calculus, now delta will come into differential calculus. Delta p by delta theta, delta phi cross delta p by delta theta. First place, theta is constant, the way we took two circles. And at the second place, the phi is constant. What is p? Okay, what is p now? This is what, if you watch previous video, we calculated through theta and phi only. But in that theta and phi, we brought through other way. This time we are bringing through vector way. That is the difference. So vector way means how much it changes, and if angle is changing one unit, then how much this vector is changing. Difference of vector gives the tangential vector, and magnitude is the length. This is different approach. Now we can proceed the way proceeded in the last example. Now position vector can be written as r unit vector in pure spherical coordinate system. This is r vector, radius vector, and if I talk about the theta vector, then this is the arc line. If I take position vector means position vector of point P. If this is a sphere and I have taken any point P here, what is the position vector of point P? Watch our previous video. Point P in the spherical coordinate system can be written in r, theta and phi. R is r, so r unit vector, plus for theta it will be arc. Arc is, if this is the arc, now theta has many circles. Everywhere theta is there. Can you see? If I chop anywhere at the horizontal manner, then it will result in a circle. Okay, then theta is everywhere, but radius is varying. Makes sense? At any moment, what is the radius? If this is the radius, if this is the radius of the sphere, this is the radius of the sphere in the xy plane. This is radius of the sphere anywhere, making phi angle with the vertical. Keeping phi angle constant, we can rotate like this. What is this radius? What is this radius? The radius is, if this is r, this is phi, r sine phi is the radius. What is this arc? Then r sine phi, that is the radius of that circle, r sine phi, okay, theta, whatever theta I am moving. So position vector P on the sphere is r unit vector plus r sine phi theta unit vector, plus now the vertical arc is r phi, so r phi unit vector, dp by d phi, keeping theta constant. So dp by d phi will become dr by d phi 0. R is constant for the surface area. R sine phi d theta by d phi, theta is constant 0. R phi unit vector by d phi, r phi unit vector will be r phi unit vector, cross product dp by d theta, where r is anyway constant, phi is constant, dr by d theta 0. R sine phi d theta by d theta, theta unit vector, r sine phi, r d phi by d theta 0. It will come as r phi unit vector cross r sine phi theta unit vector, magnitude. It will come as r square sine phi magnitude, d theta d phi. R is constant, I can take outside r. It will become now, otherwise it would have become r square sine phi r unit vector. Phi unit vector, theta unit vector cross product will result in r unit vector. Area vector is like this, perpendicular to the surface along the r unit vector. R square I can keep outside, sine phi d theta. Phi is 0 to pi and theta 0 to 2 pi. It will come as 4 pi. Someone can calculate. It will come as 4 pi. 2 into 2 pi, 4 pi. 4 pi r square is the surface area. Through the repeated summation, we can calculate. We will see probably one or two more sessions we will take. We will see other scenario in that. People would say, I don't know about this spherical coordinate system. That is r unit vector, r sine phi theta unit vector, and r phi unit vector. We know as r sine phi cos theta I, r sine phi sine theta j, r cos phi k. This much we know in a spherical coordinate system. We will take through that also in calculating the surface area, and we will recalculate the surface area of a circle in 3D model. Okay, that we will do. These explanations are not available in any of the MOOC. Please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone number.